All right, welcome to the video on solving systems using matrices. So in this video, you are going to learn 2 ways to solve systems using matrices by hand, and then how to do it in your calculator, which is so exciting. So we're going to start with a warm-up of solving these systems by hand using substitution or elimination. So you can go ahead and pause the video and try these on your own. All right, so I'm going to tell you what you should have gotten as an answer. If you got that, then great. You can skip through this next part and move on to the matrix stuff. So the first one is the ordered pair 2, -1. And then the second one is the ordered triple 1, -1, 2. If you got that, fast forward through me doing these 2 problems. But if you didn't, here's me explaining both of them. Okay, so on this one here, I'm going to use elimination. I'm going to get my x's to eliminate. And you could get your x's or y's to eliminate. So I'm going to get the top one to be 10x. And then the bottom one, I'm going to get to be -10x. All right, so now I have 10x plus 8y is equal to 12. And I have -10x minus 15y is equal to -5. Cancel. I have -7y is equal to 7, so y is equal to -1. Plugging -1 back in for y, I have 5x plus 4 times -1 equals 6. 5x minus 4 equals 6. 5x equals 10. So x is 2. So then remember, you're writing your answer as an ordered pair because this is a point of intersection to -1. All right. Let me box that so I don't lose my answer there. Okay, next one right here. This is a ordered triple solution. You have x, y, and z you have to solve for. So there's many ways to do this. The way I look at it is I see this second equation right here has no z in it already. So what I'm going to do is I'm going to take the first 2 equations, or sorry, the first equation to the third equation, and I'm going to eliminate z from those 2. That way I can then solve for x or y. Okay. So I have a 3z and a 5z, so I'm going to get one to be 15z and the other one to be -15z. So I'll get this one to be 15z, and I'll get this one to be -15z. And I could do that vice versa, but that's what I chose to do. All right, so 5x minus 10y plus 15z is equal to 45, and then -6x plus 15y minus 15z is equal to -51. All right, so now these cancel. And if I look at this, like if I would have done -5 and +3, then I would have had x right here, which would have been great, but at the same time, who cares? Because it still doesn't cancel out. All right, combining these, I have -x. I don't know why that would help me. I was just thinking, I'm like, why would that help me? Plus 5y equals -6. And now I'm going to take this. Oh, there we go. It would have helped because it would have canceled with that -x, but who cares? It's fine. And I'm going to copy that second one down. -x plus 3y is equal to -4. All right, so I'm going to multiply my first equation by -1. And I have x minus 5y equals 6. And if you would have done the vice versa, you would have already had that, is what I'm trying to say in all my stumbling. Those cancel. I have -2y is equal to 2, so y is equal to -1. All right, so now I know y is -1, so now I'm going to go to my second equation and solve for x. So I have -x plus 3 times -1 is equal to -4. So -x minus 3 is equal to -4. Add 3 to both sides. -x is equal to -1, so x is equal to 1. Lastly, I need z, so I can use the first or the third equation to get it. I'm just going to use the first one. So I have x, which is 1, minus 2 times y, which is -1, plus 3z is equal to 9. So I have 1 plus 2, which is 3. So I'm going to subtract 3 from both sides. I have 3z is equal to 6. Divide by 3z is 2. And now I can write my answer as an ordered triple. This is 1, -1, 2. Okay, so now what we're going to do is we're going to learn how to solve these systems using inverses, and then we're going to solve the first system using inverses and the second system using Gaussian elimination with row echelon form. They're interchangeable, okay? I would not solve this using inverses because we didn't touch on how to do an inverse by hand of a 3x3. So that's why I chose to do Gaussian elimination with this one. But you can use Gaussian elimination on this one or inverses. It's up to you. All right, so let's just do this and show that we get the exact same answer, 2, -1. Okay, so how you're gonna do this using inverses is that you're gonna create 3 matrices. So a linear system with 2 variables or 3 variables or 4 variables can be rewritten using the matrix equation A times X equals B, where A is the coefficient matrix, X is the variable matrix, and B is the matrix of constants. To solve the system using matrices, you're going to rewrite the system as a matrix, AX equals B, and then to solve for X, X is equal to A inverse times B. Remember why? Is because to get X by itself, we would have to use A inverse. So then you would do A inverse times B is equal to X. That's why. Okay? Oops, I meant to erase instead of highlight. All right, so let's go ahead and get our matrices. So our coefficient matrix is matrix A. That's 5, 4, 2, 3. Our variables are the X matrix equals, and then our constants are our B matrix. So 2 by 2, 2 by 1 gives me a 2 by 1. This is A, this is X, this is B. So now to solve for X, okay, we are going to use A inverse times B. Okay, so we're first going to find A inverse. So to find A inverse, remember we have to do 1 over the determinant. So to get the determinant, we're going to multiply 5 times 3 and subtract 4 times 2. So that's 15 minus 8, which is 7. Then for the matrix, we are going to switch the order of these two. So it's going to be a 3 and a 5 instead of a 5 and a 3. And then we're going to take the opposites of the other two. -4, -2. All right, multiply all of those by 1/7, and we get 3/7, -4/7, -2/7, 5/7. So not the prettiest inverse, but hey, it'll be fine, okay? So now what we're gonna do is we're gonna do A inverse times B, and this will give us our variables. All right, so we're gonna take that A inverse, 3/7, -4/7, -2/7, 5/7, and we're gonna multiply it by B, and B is 6/1. Okay, and now we are going to multiply these two. So the 2 by 2 times a 2 by 1 gives me a 2 by 1. So to get my first entry, I'm gonna do row 1 times column 1. So this is 3/7 times 6, which is 18/7, plus -4/7 times 1, which is -4/7. So 18/7 plus -4/7 is 14/7, which is 2. To get my next entry, I'm going to do, or my second entry, I'm going to multiply -2/7 times 6, which is -12/7, plus 5/7 times 1, which is 5/7. That gives me -7/7, which is -1. So now you get X is 2 and Y is -1, or the ordered pair 2, -1. So that's just another way to solve a system using matrices. Okay. All right, now we are going to solve this system using Gaussian elimination and writing the equation in row echelon form. All right, so what we're going to start off by doing is we are going to write a matrix for our system. So instead of writing 2 matrices, we're actually going to write 1 matrix, the coefficients on the variables, and then the solution. So this is going to be a 3 by 4. 1, -2, 3. I like to put a line right here to separate my solutions. 9, -1, 3, 0 z's, -4. 2, negative 5, 5, 17. Okay, so here is our matrix that we'll be using. So what we're going to do is we're going to get this in row echelon form. To get this in row echelon form, which we're going to end up using reduced row echelon form. So let me first explain what reduced row echelon form is, okay? Reduced row echelon form is where you have ones in the pivot spots of your matrix. So the pivot spots of my matrix would be here, okay? And then zeros everywhere else. So 0 here, 0, 0, 0, 0, 0, right? Reduced echelon form is to get everything in a pivot spot with everything else to the left of the pivot spots 0. And I like making, at the very least, these ones. This doesn't necessarily have to be a 1, but in the case that we're doing it, it's going to be a 1. Okay, so we're going to get it in row echelon form. So we're going to get it in, we're going to have ones here and then zeros here. Row echelon form is really only having zeros there, and then the pivot spots, to the left of the pivot spots, zeros. But we're going to get it somewhat reduced echelon form, but we don't need to have the zeros here. Okay, hopefully that was super confusing. Just kidding. All right. So what we're going to do is we are going to, if you look, there's already a 1 here, which is great, okay? But I want this to be a 0. That's my first goal, is I need that to be a 0, okay? So I'm going to leave the first row alone. It looks good. 1, negative 2, 3, 3, 9. Sometimes I don't leave enough space for my brain. 9, okay? All right, so I want this entry to be 0, right? So what I want to do is I want to take that row and combine it with another row using addition or subtraction along with multiplication if need be to get it to be a 0. So what I notice is that I can add these 2 rows together and this new entry would become a 0, right? So that's what I'm going to do. And so that I don't lose track of this, I'm going to write down exactly what I'm doing. So for this new second row, I'm combining row 1 plus row 2. All right, so row 1, and I wanted that to be in red because I have, oh my goodness, does it need to be in red that badly? OCD, sorry, style, red. I want you in red. Okay, I wanted it in a different color. All right, so now I'm going to write my new row. I'm going to combine row 1 and row 2. I'm combining these 2 rows. So that becomes 0, 1, which is great because that's what I wanted. 3 and 5. Okay. All right, so now I got this to be a 1 also, which is just a bonus that I didn't have to do that. But now, while I'm here, I also want this to be a 0, okay? So I have to use row 3 in the combination with something else. So I'm going to say I'm going to take row 3. I want you in a different color, purple. All right, row 3, so that's 2. And then I can either subtract 2 row 1s or I can add 2 row 2s. I'm going to do add 2 row 2s. Okay, so that's 2. So I'm going to take one of these and add 2 of these. Okay, so one of those and add 2 of those. So that's 2 plus negative 2, which is 0. Exactly what I wanted, right? Otherwise, I did it wrong. So row 3, negative 5, plus 2 row 2s. So that's 6. Negative 5 plus 6 is 1. I need that to be a 0, so I'm going to have to do some more work after this. 5 plus 2 times 0 is still 5. 17 plus 2 times negative 4, so 17 minus 8, which is 9. Okay, I'm doing this. This is great. All right, so I'm getting close. All that I need is this to be a 0, and I'm also going to make that a 1. I don't have to, but I'm going to. Okay? All right. So let's get that to be a 0. So I need this now. So now we're looking at this matrix. Forget that matrix up there. I want this to be a 0. So I see that I can take row 3, because that's what I need to use, and I'm going to subtract row 2. Okay? So that's my plan. I'm going to leave row 1 alone. 1, negative 2, 3, 9, 0, 1, 3, 5. And now I'm going to state what my plan is here. All right, so I said it already. I'm going to take row 3, and I'm going to subtract row 2. All right, row 3 minus row 2. So 0 minus 0 is 0. Better be. 1 minus 1, I should go like this to see it. 1 minus 1 is 0. Good. 5 minus 3 is 2. 9 minus 5 is 4. Now I could, like this is row echelon form technically. And because if you look all the pivot points, everything to the left of the pivot values, these are your pivot values, is 0, okay? But I like to get them all ones because it just makes my life easier, okay? You'll see why. All right, so I'm gonna do one last one. I'm gonna copy these 2 rows because they're ready to go. Copy, paste, lovely. All right, and then I'm gonna multiply row 3 by a half because then that will become a 1. Because remember I said I wanna get that to be a 1. You'll see why in a minute, but this step is technically unnecessary. 1/2 of row 3, I get 0, 0, and then half of 2 is 1, half of 4 is 2. Okay, all right, so now remember these were our values from our system. So this was 0x is 0y's, 1z is equal to 2. So z is equal to 2. This would have been 2z is equal to 4, z is equal to 2. So it's personal preference. It's personal preference. So now I'm gonna solve this. Okay, so z is equal to 2. All right, I'm gonna move that over because it's like in the middle of my work here. All right, so now that I know z is equal to 2, I can replace that in this equation. This equation is 0x, which I don't need to write, plus 1y, so just y, plus 3z is equal to 5. And I know what z is 2, so I can plug that in there. Y plus 6 is equal to 5, so y is equal to -1. And then lastly, this equation right here is x minus 2y plus 3z equals 9. So I'm gonna write that down. X minus 2y plus 3z equals 9. And I can plug in -1 for y and 2 for z. So I have x minus 2 times -1 plus 3 times 2 equals 9. So that's x plus 8 equals 9. So x is equal to 1. So then I get the ordered triple solution, 1, -1, 2. If you look back at the opener, these are the same exact solutions that we got in the opener, okay? Was this an easier method? When you get really good at it, I think this is an easier method. Do I think using inverses? No. So now we're gonna learn the absolute easiest method, using our calculators to do this for us, which you are gonna be allowed to do on your test, okay? So if I had to solve this, I'm gonna show you both using inverses and reduced row echelon form in your calculator. I'm gonna show you both, so I'll stick to what we had before. I'm gonna use matrices to solve this one. So once again, you need matrix A, 5, let me zoom in here, 4, 2, 3. And then you're gonna need matrix B, which is 6, 1, okay? And you're gonna do A inverse times B in your calculator. All right, so let's go ahead and do that. Open up my calculator here. All right, so first we need to enter the matrices. So to enter the matrices, you're going to hit second, and then the 4th button down in blue says matrix there. So I'm gonna hit matrix, and what I need to do first is I need to edit the first matrix. So I'm gonna call that matrix A. This is a 2 by 2, so I'm gonna put 2 by 2, and I'm gonna put in the entries. 5, 4, 2, 3. Oops, I hit 23 instead of 2, 3. And then matrix B, so I'm gonna get quit out of this, second quit. I'm gonna go back into matrices. I'm gonna move over to edit and then down to matrix B. This is a 2 by 1, 6, 1. And now I'm gonna do matrix A, inverse. Inverse is the 4th button down, times matrix B. Enter, and it's 2, -1. So we have the ordered pair 2, -1. Also, if you just needed the inverse, right? So if I just needed the inverse, I could delete this and delete this. And if I did A inverse, it would tell me these decimals. But if I hit math, enter, enter, it would turn them into fractions for me. 3/7, -4/7, -2/7, and 5/7. All right, now let me show you how to use reduced row echelon form. So you're going to need your 1 matrix once again. 1, -2, 3, 9. -1, 3, 0, -4. 2, -5, 5, 17. Okay, so this is going into matrix A, the whole thing. This is a 3 by 4, right? And then what we're going to do is we are going to use the reduce row echelon form command, and it's going to put this in reduce row echelon form, which is going to give me X, Y, and Z, okay? All right, so we are going to go to matrices, so second matrix. Oops, second matrix. We are going to edit, and then you can put it in a new matrix C, or you can just write over matrix A. I'm going to write over matrix A. This is a 3 by 4. Entries 1, -2, 3, 9. -1, 3, 0, -4. If I mistype anything, I'll know when I don't get the right answer. 2, -5, 5, 17. Okay, so you can quit out of that now, and then now you're going to go back into matrices, and you're going to move over to math. So if you look, math, if you toggle down, you should see option B is RREF, reduced row echelon form. You can go ahead and click that, and then put matrix A in there. All right, so you can see it's giving us in reduced row echelon form. It's giving us the zeros to the left of the pivot points and to the right. So this says X plus 0Ys plus 0Z is 1. So in other words, X is 1. 0X plus Y plus Z is equal to -1, so on and so forth. So it gives us the ordered pair, 1, -1, 2. Most people prefer this because it's one less matrix to enter, and it just gives you your answers without having to do A inverse times B. All right, so now what I want you to do is go ahead and pause the video and try this one. You can do using RREF or inverses. It doesn't matter to me. And then come back and check your answers. I'm just going to go into Schoology and see. Actually, I'm not going to go into Schoology where I have my answer keys. I'm going to go right here where I already made an answer key. And this is what you get. Scroll to the bottom here. There you go. Okay, so it doesn't matter which one you did. Calculator commands look like this for if you're using inverses. Calculator commands look like this if you're using reduced echelon form, but either way, you should get this as an answer. All right, that's it for today.